April 1944. The Pacific Theater had become a graveyard of steel and fire. Aircraft carriers, floating cities of fuel, ammunition, and flame, lived under the constant threat of catastrophic destruction. A single spark could turn a hangar deck into an inferno in seconds. Yet aboard one American carrier, an experimental safety system inspired ridicule and disbelief among the crew. Steam fog generators, designed to smother fires by flooding compartments with dense, suffocating vapor. The engineers swore by the physics. The sailors called it madness. Then came the day when laughter turned to silence. It began with routine maintenance, a fuel line rupture during refueling operations on the hangar deck. Aviation gasoline spread across the steel floor in seconds, pooling beneath parked aircraft loaded with ordnance. When the ignition came, a dropped tool, a spark from damaged wiring, perhaps friction itself, the fire erupted with a roar that shook the entire ship. Flames climbed the aircraft fuselages, reaching towards stacked bombs and torpedoes. The crew had minutes, perhaps less, before the explosion that would tear the carrier apart. In that moment, an engineer made a decision that defied every instinct. He activated the steam fog system. Within seconds, a wall of white vapor poured into the hangar deck, swallowing the fire in a dense, suffocating cloud. Men disappeared into the fog, choking and blind, unable to see their own hands. The heat remained, but the flames, impossibly, began to die. This is the story of that day, of the men who laughed at steam fog until it saved their lives, of the fragile line between survival and annihilation aboard a warship at sea, of the quiet terror that follows salvation, when men realize how close they came to vanishing entirely, and of the engineers whose calculations were dismissed as fantasy, until physics proved stronger than fire. Before we continue, subscribe and turn on the bell. Here we tell real, untold stories of World War II, stories of innovation, desperation, and the fragile moments when survival depends on believing the unbelievable. Chapter 1. The system. No one trusted. The steam fog generators were installed during the carrier's final refit in early 1944, tucked into bulkheads along the hangar deck like unwanted passengers. To the engineers who designed them, the system represented elegant simplicity. Superheated steam released under pressure would instantly vaporize into dense fog, displacing oxygen and smothering flames faster than any chemical suppressant. To the sailors who maintained the hangar deck, the system seemed like a death trap waiting to happen. "They want to cook us alive," one aviation mechanic muttered during the installation briefing, his voice carrying across the crowded ready room. Laughter rippled through the assembled crew. The image was absurd, flooding a burning compartment with steam hot enough to scald flesh, turning the hangar deck into a pressure cooker while men scrambled to escape. The engineers insisted the fog would cool rapidly, that the vapor would smother fire without cooking anyone. But physics textbooks offered little comfort to men who worked daily among aviation fuel and live ordnance. The chief engineer, a soft-spoken man whose calculations filled entire notebooks, tried to explain the thermodynamics during mandatory safety drills. He spoke of latent heat, oxygen displacement, rapid cooling through expansion. His words disappeared into skeptical silence. One petty officer asked the question everyone was thinking: what happens if we're still inside when you trigger it? The engineers' pause before answering told them everything they needed to know. Still, the drills continued. Every week, sirens would blare and the crew would practice evacuating the hangar deck, while engineers simulated steam fog deployment. The exercises felt like theater, scripted movements through a scenario everyone hoped would never occur. Men memorized evacuation routes, learned to recognize the distinct hiss of steam valves opening, practiced holding their breath and crawling toward exits they couldn't see. But beneath the routine lay a persistent doubt: would this experimental system save them, or simply give them a different way to die? The carrier's captain, a veteran of 2 Pacific campaigns, had approved the installation with reluctance. His primary concern wasn't the technology itself, but the crew's faith in it. A fire suppression system only worked if men trusted it enough to use it in crisis. Yet every time he walked the hangar deck, he heard the same jokes, saw the same sidelong glances at the steam fog generators mounted overhead. The system might be brilliant engineering, but it was also a psychological gamble, betting that in the moment of catastrophe, someone would have the courage to activate equipment that seemed as dangerous as the fire itself. By April, the steam fog generators had become part of the ship's background landscape, ignored fixtures that generated occasional maintenance complaints, but no confidence. The engineers conducted weekly pressure tests, carefully monitoring valves and checking for leaks. The crew continued their drills with mechanical precision and zero enthusiasm. And deep in the engineering spaces, the chief engineer updated his calculations one more time, running the numbers that promised salvation through suffocation, praying he would never need to prove them correct. None of them knew that within days, a ruptured fuel line would transform their skepticism into desperate prayer, that the laughter would die with the first roar of ignition, that the system they mocked would become the only barrier between survival and annihilation. That steam fog, dismissed as dangerous fantasy, would prove itself in the seconds that separated life from obliteration. The carrier sailed west toward combat operations, carrying its experimental salvation system into waters where fire was not an experiment, but an inevitability. Chapter 2. The Fuel Line Rupture. The morning of the incident began with oppressive humidity and the smell of aviation gasoline that never quite left the hangar deck. Refueling operations were underway, a routine procedure performed hundreds of times, connecting fuel lines to parked aircraft while maintaining strict protocols against sparks or open flame. The deck was crowded with aircraft awaiting sortie preparation, their fuselages packed with bombs and torpedoes, their fuel tanks empty and waiting. The fuel line serving the starboard side had been flagged for replacement during the previous maintenance cycle, but replacement parts hadn't arrived. The line showed minor wear, acceptable under normal circumstances, manageable with careful monitoring. The chief aviation machinist authorized its continued use, noting the wear in his log but judging the risk acceptable for one more refueling cycle. It was the kind of calculated decision made daily aboard every carrier in the fleet, balancing operational necessity against imperfect equipment. At 08:47 hours, during the refueling of the fourth aircraft in line, the fuel line ruptured. The failure was catastrophic and instantaneous. High-pressure aviation gasoline exploded from the torn line, spraying across the hangar deck in a wide arc that coated steel flooring, aircraft landing gear, and the legs of 3 nearby sailors. The emergency cutoff valve, designed to stop fuel flow within seconds, closed as intended, but not before hundreds of gallons had already escaped. Gasoline pooled beneath the parked aircraft, spreading rapidly across the slightly tilted deck, seeking lower ground, filling drainage channels, creating an expanding lake of volatile liquid. The smell hit before the visual comprehension, the sharp, suffocating odor of aviation fuel in dangerous concentration. Men looked down to see gasoline lapping at their boots, reflecting overhead lights in rainbow patterns. For 3 seconds, perhaps 4, the hangar deck existed in frozen silence. Everyone understood what they were seeing. Everyone knew what came next. The fire alarm sounded, its piercing shriek cutting through paralysis. Men began running toward exits, their boots splashing through gasoline as they fled. Damage control teams rushed forward with foam dispensers, following protocols drilled into muscle memory. Officers shouted evacuation orders, their voices barely audible over the alarm and the pounding of running feet. The entire choreography of emergency response unfolded with practiced precision, but precision couldn't stop physics. The ignition source was never definitively identified, perhaps a tool dropped by trembling hands, perhaps an electrical spark from damaged wiring, perhaps simple friction between metal surfaces. The investigation later listed undetermined origin in its official report. What mattered was the result. At 08:49 hours, 2 minutes after the rupture, the gasoline ignited. The fire came with a roar that felt like physical impact. Flames raced across the pooled fuel, climbing instantly to 20 feet in height, engulfing the lower fuselages of 3 parked aircraft. Heat radiated across the hangar deck in waves that drove men backward, gasping. The foam teams aimed their dispensers at the base of the flames, but aviation gasoline burned too hot, too fast. The foam evaporated on contact, offering no meaningful suppression. Now tell us in the comments where you're watching from, and how far these forgotten wartime stories have reached. Your voice helps keep memory alive. Chapter 3. The Impossible Decision. In the Damage Control Center, the chief engineer watched the hangar deck monitors with the detachment of someone observing his own nightmare, made real. The fire had spread to 5 aircraft now, flames climbing toward bomb racks and torpedo mounts. The temperature readings from deck sensors climbed past survivable thresholds. Foam suppression had failed. Water would spread the gasoline fire across the entire deck. Chemical suppressants couldn't reach the flames fast enough. He had perhaps 90 seconds before the ordnance detonated. His hand moved toward the steam fog activation panel, then stopped. The system had never been tested under actual fire conditions. The theoretical models promised oxygen displacement and flame suppression, but theories didn't account for the chaos of burning aircraft and panicked men still trapped on the hangar deck. If he activated the system now, the dense steam fog would blind everyone inside, turning evacuation into a death sentence of its own. Men would stumble into flames they couldn't see, collapse from heat they couldn't escape, suffocate in vapor they couldn't breathe. But if he didn't activate it, the ship would explode. The radio crackled with reports from the hangar deck, desperate voices calling for more foam, for water, for anything. Someone screamed about men trapped behind the fire line, unable to reach the exits. Another voice reported ordnance cooking off, small explosions that meant the main detonation was seconds away. The fire was no longer controllable by conventional means. Everyone in the damage control center knew it. The captain's voice came through the command circuit steady despite the crisis. Options? The chief engineer looked at the activation panel, at the rows of green lights indicating ready systems, at the single red button that would flood the hangar deck with suffocating vapor. His calculations had been perfect. The physics was sound. Steam fog would displace oxygen faster than the fire could consume it, would cool the flames through rapid heat absorption, would create conditions incompatible with combustion. The theory was flawless, but theories didn't burn. Men did. Steam fog, he said quietly. It's our only option. The silence in the damage control center felt like judgment. Everyone understood what he was proposing, flooding a compartment full of their own crew with superheated vapor, gambling that the fog would extinguish the fire before it cooked anyone alive. It violated every instinct of naval firefighting, every protocol that prioritized crew safety above equipment preservation. It was the kind of decision that destroyed careers if it failed, that haunted men forever if it succeeded. The captain's response came after a pause that lasted centuries. Do it. The chief engineer's hand moved to the activation panel. He flipped up the protective cover over the steam fog release button, feeling the cold metal beneath his fingers. On the monitors, flames continued climbing. Temperature sensors showed readings approaching explosive thresholds. Men were dying in there, or would be soon. He pressed the button. Deep within the ship's engineering spaces, valves opened with mechanical precision. Superheated steam, held under pressure at temperatures exceeding 400 degrees Fahrenheit, rushed through pipes toward the hangar deck. The system's pressure regulators modulated the flow, designed to create maximum fog density with minimum scalding risk. The entire sequence took less than 2 seconds from activation to deployment. On the hangar deck, the first sign was a hiss that cut through the roar of flames. Then the fog came. Chapter 4. The White Wall. It poured from overhead vents like a physical substance, a dense white wall that moved with impossible speed. The steam fog descended in a cascade that swallowed the hangar deck from overhead to floor in seconds, erasing visibility so completely that men standing 5 feet apart vanished from each other's sight. The temperature, paradoxically, began to drop as the superheated steam expanded and cooled, its latent heat dissipating into the vast volume of the hangar space. The fire disappeared, not gradually, not with the slow suffocation of foam or chemical suppressant, but with shocking immediacy. The flames that had climbed 20 feet high simply ceased to exist, smothered by fog so dense it displaced every molecule of oxygen. The roar of combustion died to silence, broken only by the hiss of continuing steam release and the confused shouts of men trapped inside the white void. Sailors caught in the fog described it later as drowning in clouds. The vapor clung to skin and clothing, condensing into moisture that made everything slick and heavy. Breathing became labor. Each inhalation brought wet air that felt like drowning, that triggered reflexive coughing, that made men panic despite knowing panic would kill them faster than the fog. Visibility extended perhaps 6 inches. Men held their hands directly before their faces and saw only white. Those near the exits had practiced this scenario a dozen times during drills. Muscle memory took over where sight failed. They dropped to hands and knees where the air was marginally clearer, and crawled toward exits they remembered but couldn't see. Some found their way by following deck seams with their fingers, counting rivets, using touch to navigate through blindness. Others simply crawled in what they hoped was the right direction, praying they wouldn't encounter flames that still burned somewhere in the white void. Men trapped deeper in the hangar deck faced impossible navigation. The fog had erased every landmark, every visual reference. Aircraft that had been burning minutes earlier now existed only as vague, dark shapes in the white. their outline suggesting direction, but offering no certainty. Some sailors followed voices, calling out to each other through the vapor, creating human chains that led toward exits. Others simply stopped moving, overcome by disorientation and terror, waiting for rescue or death with equal resignation. The heat remained, though diminished. The fire was extinguished, but the steel deck still radiated warmth from minutes of intense burning. Men crawling through the fog encountered pockets of scalding vapor, where localized heating had created temperature gradients. Burns came not from flames, but from touching heated metal, aircraft skin still hot enough to sear flesh, deck plates that had absorbed fire's energy, pipework that glowed red beneath the white. In the damage control center, monitors showed nothing but white. The camera feeds had become useless, transformed into blank screens that offered no information about who was escaping and who remained trapped. Temperature sensors showed rapid cooling. The system was working exactly as calculated, but the human cost remained unknown. The chief engineer stared at the useless monitors, wondering if his perfect calculations had just killed everyone in the hangar deck. Rescue teams equipped with breathing apparatus entered from the forward access points, moving through the fog with practiced caution. They called out constantly, listening for responses, following voices toward trapped sailors. The fog made rescue operations surreal, finding men by sound alone, grasping arms that appeared suddenly from white void, leading them toward exits they couldn't see but had to trust existed. The steam fog deployment lasted 4 minutes before the system automatically shut down, having achieved its objective. As the vapor began to dissipate, rising toward overhead vents and thinning into visibility, the hangar deck revealed itself like a photograph developing. Blackened aircraft hulls, charred deck plates, foam residue mixing with condensed steam, and men, dozens of them, sitting or lying where the fog had stopped them, coughing and gasping but alive. The fire was gone, completely, impossibly gone. Where flames had threatened to detonate the ship's entire ordnance magazine, now only wet metal and smoke residue remained. Chapter 5. Aftermath of Silence. The casualty count came in slowly, assembled from medical reports and deck-by-deck verification. 17 men had sustained burns during the initial fire, most minor, 3 serious enough to require evacuation to the medical bay. 8 suffered respiratory distress from steam fog inhalation, treatable but requiring monitoring. 2 men remained unaccounted for during the first hour after the incident, later found unconscious in a tool storage compartment where they had crawled seeking refuge from the fog. 0 fatalities. The damage assessment told an equally improbable story. 5 aircraft destroyed or damaged beyond shipboard repair, losses that would hurt operational capability, but not cripple the carrier. Hangar deck structural damage limited to localized steel warping and paint scorching. No ordnance detonation, no catastrophic hull breaches, no flooding. The ship remained combat capable, able to continue operations after cleanup and minor repairs. It should have been a celebration. The experimental system had functioned exactly as designed, preventing what should have been a disaster that sent the entire carrier to the bottom. The chief engineer's calculations had proven correct. Steam fog had extinguished an aviation fuel fire that conventional methods couldn't touch. The technology worked, but the men who had been inside the hangar deck when the fog descended did not celebrate. They gathered in small groups during off-duty hours, speaking quietly about the experience, trying to articulate what it felt like to be swallowed by white void. They talked about the disorientation, the panic of blindness, the sensation of drowning on dry land. Some admitted they had given up during those 4 minutes, had stopped trying to find exits and simply waited for death. Others described the terror of hearing voices but seeing nothing, of reaching out and grasping only vapor, of losing all sense of direction until they couldn't remember which way was forward or back. "It saved us," one aviation mechanic said during a late-night gathering in the berthing area, his voice carrying no gratitude. "But I'll never forget those 4 minutes. Never." Others nodded in silent agreement. The steam fog had extinguished the fire, but it had also extinguished something else. The comfortable assumption that rescue came with visibility, that survival looked like something you could see and understand. The fog had forced them to survive while blind, to trust in physics they didn't comprehend, to surrender control completely to engineers and calculations and vapor that might cook them or save them with equal mathematical precision. If this story has moved you, leave a like. It helps others discover how humanity can survive even inside the walls of captivity. Chapter 6. The Engineer's Burden. The chief engineer never spoke publicly about his decision to activate the steam fog system. In his official report, he described the sequence of events with clinical precision: fuel line rupture at 0847, ignition at 0849, foam suppression failure, steam fog deployment at 0851. The language was technical, emotionless, designed to document facts rather than feelings. He never mentioned the 3 seconds he had hesitated before pressing the activation button, never recorded his certainty that he was about to kill everyone in the hangar deck. His assistants understood. They had watched him make the decision, had seen his hand shake as it moved toward the panel, had heard the captain's authorization that made the choice official, but didn't make it any less his burden to carry. In the days after the incident, they noticed subtle changes: how he rechecked valve settings twice instead of once, how he walked the steam fog distribution system daily, running diagnostics that had been performed hours earlier, searching for any flaw that might have been there all along. The system's success had validated the engineering, but validation brought its own weight. The chief engineer now knew with certainty that his calculations could save hundreds of lives, but he also knew that those calculations required gambling with the lives of the men who trusted him, that choosing to activate steam fog meant choosing to blind and suffocate your own crew in the hope that physics would work faster than panic. Other carriers in the fleet began requesting steam fog system installations. The incident report circulated through naval engineering channels, treated as proof of concept for an experimental technology that had moved from theory to demonstrated capability. Engineers at shipyards and naval research facilities studied the data, refining the designs, calculating optimal fog density and deployment timing for various compartment sizes. But the requests for installation came slowly. Carrier captains read the technical reports and the casualty counts, understanding both what the system could do and what it demanded of crews who had to trust it. The technology was sound, the physics was proven, but the psychological requirement, asking men to remain calm while being swallowed by suffocating vapor, that requirement gave even enthusiastic advocates pause. The chief engineer received commendations for his innovation and his decision-making under crisis conditions. The awards felt hollow. He hadn't been innovative, he had been desperate. He hadn't made a decision, he had gambled everything on calculations that could have been wrong. The fact that he had been right didn't erase the memory of those 3 seconds when he believed he was about to become responsible for the death of everyone in the hangar deck. He kept the award citations in a drawer and never looked at them again. Chapter 7. The drills that followed. The steam fog drills changed after the incident. Where previously they had been perfunctory exercises performed with skeptical compliance, now they carried the weight of witnessed reality. Sailors who had been inside the fog during the fire became impromptu instructors, teaching others what to expect when white void swallowed the hangar deck. "It's not like smoke," one experienced machinist explained during a training session, addressing newly assigned crew members. "Smoke you can wave away, can find pockets of clear air. The fog is total. When it comes, you won't see anything. Your hand in front of your face will disappear. Your only navigation is memory and touch." The drills incorporated this knowledge. New procedures emphasized pre-memorization of exit routes, counting steps from duty stations to escape hatches, learning to identify direction by feeling deck seams and pipe runs. Men practiced crawling while holding their breath, simulating the respiratory distress that came with inhaling saturated vapor. They learned to recognize the specific hiss that preceded fog deployment, training themselves to drop immediately and begin moving toward exits before visibility vanished. The psychological preparation became as important as the physical training. Officers addressed the panic that came with sudden blindness, teaching breathing techniques to manage the sensation of suffocation, emphasizing that 4 minutes of fog deployment was survivable if men didn't waste energy fighting the inevitable. "Trust the system," they repeated. "Trust the physics. Trust that the engineers knew what they were doing." But trust came hard. Even among men who hadn't experienced the incident firsthand, the stories circulated with enough detail to inspire unease. The steam fog system existed in a peculiar space in the crew's collective consciousness, simultaneously their best hope for surviving hangar deck fires and their nightmare of death by suffocation. Both perceptions were accurate. Both were terrifying. The carrier's captain made steam fog training mandatory before every combat operation deployment. He attended the sessions himself, sitting with the crew during briefings, asking questions about procedure and equipment reliability. His presence sent a clear message. This system was not experimental anymore. It was operational reality. Everyone needed to understand it, trust it, and be ready to survive it. Years later, veterans of that carrier would remember the drills more vividly than many actual combat operations. The routine of practicing blindness, of rehearsing terror, of learning to surrender control to vapor and physics. Those exercises marked them in ways that enemy fire somehow didn't. They had trained to be rescued by the thing that terrified them most. Chapter 8. The technologies spread. By 1945, 17 American carriers had been fitted with steam fog systems. The installations varied in design sophistication, but all followed the core principles validated by that April morning. Rapid oxygen displacement through dense vapor, thermal cooling through latent heat absorption, and deployment speed measured in seconds rather than minutes. The technology had moved from experimental innovation to standard fleet equipment. Other incidents tested the systems. A small galley fire aboard one carrier, extinguished in 30 seconds. An electrical fire in a ready room, smothered before it could spread to stored ordnance. A fuel spill that ignited during night operations, suppressed so quickly that most of the crew never realized the ship had been seconds from catastrophe. Each successful deployment reinforced the system's reputation, added data to the engineering models, and confirmed that steam fog could do what conventional firefighting methods couldn't. But the incidents also accumulated stories that echoed the first, tales of men swallowed by white void, of blind crawling through vapor, of terror mixed with salvation. The technology never lost its psychological edge. Even routine deployments left men shaken, reminded viscerally of how survival sometimes required surrendering to something you couldn't see or control. Naval historians began documenting the steam fog era, interviewing engineers and sailors, collecting technical reports and personal accounts. The story that emerged was one of innovation, born from necessity, of technology that worked brilliantly, but demanded psychological costs that numbers couldn't measure. The steam fog systems had prevented dozens of catastrophic fires, had saved thousands of lives, had kept carriers operational through conditions that should have sent them to the bottom. Yet no one who experienced deployment firsthand ever called it comfortable or easy. The fog saved you, but it terrified you in the process. That paradox defined the technology's legacy. Effective but never welcomed, trusted but never embraced. By war's end, steam fog systems had become commonplace enough that new sailors learned about them during basic training, before ever setting foot on a carrier. The technology was no longer experimental or controversial. It was simply part of the carrier's safety infrastructure, like fire extinguishers and damage control stations. The fear remained, but familiarity had worn down the sharp edge of disbelief. The chief engineer who had pressed that first activation button survived the war and returned to civilian life. He never worked in naval engineering again, choosing instead a quiet career in industrial systems design. Colleagues who knew his wartime service sometimes asked about the incident, about what it felt like to make that decision. He never gave detailed answers. The calculations had been correct. The system had worked. Men had lived who should have died. That was all he ever said. Chapter 9. The Fragile Piece of Salvation. The carrier that first proved steam fog technology combat viable survived the war intact. She participated in 3 major Pacific campaigns, conducted hundreds of sorties, weathered kamikaze attacks and storm damage, and the grinding wear of continuous operations. The Hangar-Deck fire in April 1944 became one line in her operational history, an incident noted, investigated, documented, and filed away. But for the men who had been there, who had watched flames climb toward ordnance or felt white fog erase the world, that morning never quite filed away. Years after the war ended, veterans of that carrier gathered at reunions and spoke about the incident with a mixture of gratitude and lingering unease. They acknowledged that steam fog had saved the ship. They recognized the engineering brilliance. They understood intellectually that the system had functioned exactly as designed. Yet when they spoke about those 4 minutes inside the white void, their voices carried an edge that combat stories somehow lacked. The fog had saved them, yes, but it had saved them by making them helpless, by stripping away every sense except touch and sound, by forcing them to trust in calculations they didn't understand, and technology they couldn't see working. Salvation had come through surrender. The incident left no visible scars. The damaged aircraft were replaced. The scorched deck plates were cleaned and repainted. The fuel lines were upgraded to prevent future ruptures. Within weeks, the hangar deck looked exactly as it had before the fire, with no physical evidence that catastrophe had been seconds away. But the men carried the memory like a weight that never lightened. Not the memory of burning, but the memory of being saved by something that felt like drowning. The chief engineer's calculations lived on in technical manuals and fleet training materials. His decision, to activate an experimental system in actual combat conditions, gambling everything on physics and vapor and hope, became a case study in crisis leadership. Engineering students analyzed his choice, debated the ethics of his gamble, studied the thermodynamics that made steam fog possible. None of the analysis captured what it felt like to press that button, knowing men might die because of it. Decades later, maritime fire suppression systems evolved beyond steam fog. New technologies offered suppression without blindness, rescue without terror, salvation without the psychological cost of surrender. But the engineers who designed these newer systems studied the steam fog era carefully, learning not just about thermodynamics and oxygen displacement, but about what technology demands from the humans who must trust it with their lives. The carrier was eventually decommissioned, cut apart for scrap metal that became cars and buildings and bridges. The steam fog generators were removed during the scrapping process, salvaged by a naval museum that displayed them alongside technical diagrams and incident reports. Visitors read the placards explaining how the system worked, how it had saved lives, how innovation sometimes emerged from desperation. The museum display never mentioned the 4 minutes of white void, never described the sensation of surviving while blind, never captured the peculiar burden carried by men who were rescued by their own terror. Some stories resist documentation. Some truths exist only in the memory of those who lived them. The last reunion of that carrier's crew took place in 1993, attended by 37 veterans whose average age exceeded 70. They gathered in a hotel conference room decorated with photographs from the war years, sharing stories that had been told and retold until they achieved the polished quality of ritual. Near the end of the evening, someone mentioned the steam fog incident. The conversation stopped. Men who had been laughing moments before grew quiet, their faces carrying an expression that younger attendees couldn't quite read. Not quite fear, not quite gratitude, something more complex than either. They sat in silence for nearly a minute, remembering white void and blind crawling and salvation that came with suffocation. Finally, the oldest veteran present, a former aviation mechanic who had been trapped deepest in the hangar deck when the fog deployed, raised his glass. "To the fog," he said simply. The others raised their glasses in silent acknowledgement, drinking to the thing that had saved them by making them helpless, that had proven physics stronger than fire, that had given them 40 more years of life by taking away 4 minutes of sight and breath and control. They never explained the toast to anyone who hadn't been there. Some debts resist articulation. Some salvations remain forever complicated. Subscribe to our channel to uncover more hidden stories of World War II, stories of resilience, memory, and redemption. Thank you for watching.